From the beautiful South Studios of Way Happy, this is Mr. Meyer and higher order derivatives. So we know what a derivative is, right? You learned a little trick called the power rules, and we're going to learn more rules, but let's talk about higher order derivatives real quick. So the first thing I'm going to do is when you take a derivative, that's called the first derivative. We call it y prime, we call it dy dx, whatever. But that is the first derivative. Now, if there's nothing stopping you from taking the derivative of a derivative. So therefore, you can, and we call that the second derivative, or y double prime, or d squared y over dx squared, right? So that's called the second derivative. Now, the second derivative would be an example of what we call a higher order derivative. So when you do a derivative of a derivative, we call that a higher order derivative. So you can go ahead and take, the first derivative or the second or the third or the fourth, or, forever. You can take as many derivatives as possible until eventually you're just going to get zeros. But each one of those has their own notations. You can see with double primes and triple primes. And then we kind of switch to these parenthesis fours, so that doesn't look like an exponent, so people know, like, oh, this person means take the fourth derivative. They don't mean y to the fourth power. And so you can kind of look through there and make sure you get used to that notation. I don't know which one you're going to see, so make sure you get kind of comfortable with them all, and I'll try to jump around in all the different forms. All right, let's try an example here. You can see my question is, I want you to take the fourth derivative of that mess. All right, well, these are all nice simple powers, so we can just go ahead and apply the power rule. So if I'm going to first take d dx, or the first derivative, all right, I'm going to get negative 40x to the 7th plus 12x to the 5th minus 27x squared plus 32. And lo and behold, the derivative of -1 is 0. All right, now let's take the second derivative, because that would be our next step. So d squared of dx squared. And when I go ahead and take that, then we're going to go ahead and do that derivative, which would be negative 280x to the 6th. Again, just multiplying out front and powering down by 1, plus 60x to the 4th minus 54x. Well, that was the second derivative, so why not go to the third derivative, d cubed over dx cubed, which now these numbers get a little bit bigger, but negative 1680x to the 5th plus 240x to the 3rd minus 54. And finally, we will get to what they wanted. They wanted the fourth derivative, d4 over dx to the 4th. Actually, I don't need the parentheses there because you got that weird d and nobody would think anything else of it. And so if I'm going to go ahead now and figure out this fourth derivative, I got to do 5 times 1680, ouch, which is negative 8400 x to the 4th plus 720. Oh, I don't know what just happened there. Plus 720 x squared. And there is your higher order derivative, or in fact, your fourth derivative of the original problem. So we took 4 derivatives there, all derivatives of derivatives. And those are higher order derivatives. All of them are, but we were looking for a specific one. All right, let's try another one. Let's look at this one now. I don't want to do this. This is quotient rule, and that's a mistake. So I need to do f of x is equal to 1 over x minus 1. That should be better. All right, find the second derivative of that. All right, well, let's find the first derivative then, which is, first thing you might want to do is rewrite this as x minus 1 to the -1 power. So what does that mean? That means bringing the exponent out front, -1, to the x minus 1, and then power it down by 1, so -2. All right. Now there's a little trick in here because there's chain rule effect, but it doesn't affect us in any one because that x is has a 1 in front, so that's good news. All right, that's our first derivative. Then we can go ahead and take the second derivative of this bad boy. Again, I'm going to bring the 2 out in front and get x minus 1, and then power it down by 1, so the -3rd. Can pretty that up a little bit by doing 2 over x minus 1 to the 3rd, and that is your second derivative of f of x. So there you go. All right, and one last one. Why not give you a radical? And so if I want to do this last one, I go, all right, we got the fourth derivative given to us, and I want to find the fifth derivative. So I have to take the derivative one more time. So this is 2 times x to the half power. Again, let us go ahead and take that fifth derivative using our power rules. So a half comes out front. Somehow that happened. So a half comes out front, and it gets multiplied to the 2, and then power down the exponent by 1, and you would get to the negative half power. Again, I can clean that up. A half of 2 is just 1. Those cancel out, and I get x to the 1 over x to the half, or 1 over the square root of x. What the heck is going on? 1 over the square root of x would be our final answer for that derivative, the fifth derivative of x. And there you have it. Higher order derivatives, a fun little fact about them. Remember that we always tell you the original equation is the position and you can find average velocity and stuff like that. Well, then when you take the first derivative, we say that's the instantaneous velocity, right? So the first derivative gives us the instantaneous velocity at that given time. And then if you take the second derivative, by the way, that instantaneous velocity can be positive or negative because it's giving you a direction. However, if you talk about speed, speed is always positive. So you take the absolute value of velocity and that's speed. The second derivative is the acceleration. It's the derivative of the velocity. So acceleration is the second derivative. That's it. Have a great day. Stay happy, and I'll see you tomorrow.